Okay, so I think we are live now. So thanks everyone for joining today. Today we're going to be talking about stateful application. It's going to be all about databases, and the title is 5 tips to successfully migrate your database to Kubernetes. So I don't know if you guys have been following the Kubernetes communities and different events or reports that have been pushed out. But there's a big trend, which is to really run now stateful workload within Kubernetes and in particular our database. So, and we're going to be talking about this today, really. So my name is Nick Vermondy. I'm a principal developer advocate with Ondat. And before joining Ondat, I've worked around 4 or 5 years on Kubernetes, especially around networking with the ACI CNI. Now I've been with Ondat for about 1 month, so more specifically focusing on the data service layer. And today I'm very happy and thrilled to get with me Guy from Komodor. So Guy, if you want to introduce yourself.
Yeah, hey, nice to meet you. I'm from Komodor. I'm working for like 2 months as a solution engineer. Previously, I used to develop private clouds on a company called Zadara. And before that, I used to run OpenShift and Kubernetes for a long time. Very exciting to be here and talk about databases and stateful sets.
Yeah, hopefully this is going to be a fun topic. So the program for today, what you guys can and girls can expect. We're going to bring a little bit of context behind why running database, why running stateful workloads within Kubernetes, and why now. We're going to take a look at all the patterns and Kubernetes native benefits that you can get out of just running those stateful apps. And of course, we're going to go a bit deeper in terms of considerations for databases and take a look at the DevOps ecosystem, what we can leverage there to make your database migration into Kubernetes a success. So we're going to bring a couple of demos there. So today we're going to be using MongoDB with a Kubernetes operator. And we're going to see different things, stateful sets, how to operate the database. So hopefully you will be able to learn one thing or two. In terms of what are the prereq for today, so hopefully you guys know a little bit about Kubernetes. So that's the kind of expectation. You know what we're talking about. You can, probably do more than just spell it, right? So let's get started. So first off, with the title, is it really a good idea to run your database in Kubernetes? Fundamentally, if you replace Kubernetes by another technology, this is nothing that is really new in terms of run databases into commoditized platform. So if you are old enough like me, like 10 years ago, if you were already in the industry, there were the same debates, but replace Kubernetes by VMware or virtual machines, right? So it took some time, but as the industry and the platform get more mature, then the tool sets also evolve, the guarantee that the database will be secure, performance, and will have a lot of enterprise-grade features. As you go, as the technology evolves, then it makes sense to migrate your database to that platform to take advantage of all its benefits. And that's basically the same thing with Kubernetes. And why? It's because in Kubernetes, typically you can run 2 types of workloads. So if we start by the classic stateless workloads, this is what you run through deployment in Kubernetes, right? So it's more, the fight between pets and cattle. So the deployment, which is displayed there, is really the way to run stateless workloads into Kubernetes. So the principle is, just as a quick reminder, maybe some of you already know that, but just to set the level here, a deployment in Kubernetes is just a group of container or pods that serve the same service. So you can place them behind a VIP, which is the service object inside Kubernetes, right? And all the different pods composing that particular deployment do the same thing, right? It's exactly clone of the application. What is specific to deployment is that all those pods access the same storage, right? So when you create in a declarative format the storage requirement, the data requirement, the volume requirement, all the pods share the same requirement, which means that essentially, if they need to write as individuals, into their storage space, there's no other solution than providing a shared storage. Obviously, in the context of stateful application and in particular databases, that's pretty much a bad idea, right? Because you can't even run a database on NFS. Performance won't be there, right? There will be bad consequences in terms of your performance. And here enters the stateful set. So at the very beginning, which was around 2016, stateful sets, they were called pet sets, which is really, around this idea of cattle versus pets. And in my personal experience, the first time I saw stateful set, I was like, okay, what is this? And it was when I've deployed the first time, for me, was the Elk kind of software suite. So it's kind of complicated to get around it, but I'm going to try to put it very simply for you guys today. The idea of the stateful set is to bring a unique set of pods that are considered as totally independent piece of compute. So meaning that they have all their own identity. Their identity is stable, which means that they can be addressed with their fully qualified domain name. It means that they all access their own persistent volumes. So pod 1 will access persistent volume 1, pod 2 will access persistent volume 2. And I'm going to go a bit deeper in terms of how persistent volume claim or PVC and PV interact later. But for now, what you have to realize is every pod needs to have its own name, its own storage, and when the pod dies, it needs to be restarted on another node and still have the same identity, which obviously, you have a challenge with this. If you just rely on Kubernetes won't provide any sort of replication or encryption or anything for your volumes, which means that you have to bring your own solution to solve this issue. If a node fails, how do you ensure that the stateful pod that is located on that node can be taken over on another node that has access to the storage? And this is where Ondat will come into play. So on top, of course, stateful set should be used for stateful application and databases. And there's also on top of that another element, which is demonstrated there by Gartner in terms of the prediction around how people are going to run databases. So if you read this quickly, at the end of 2023, what Gartner assumes is that like 50% of all the databases revenue will be coming from databases that are run in the cloud. So what that means is there's two ways to consume those databases, right? Database as a service, RDS or those type, Amazon or AWS RDS or those type of solution, or you can rely on Kubernetes, which is our preferred, cloud operating system. If you're already using EKS, GKE, this type of solution, it's still considered as a cloud database. And just later, we're going to see, some arguments around why run, Kubernetes database in Kubernetes as opposed to running natively, RDS or database as a service. But here, this particular slide, what is important is that, so this is very recent. It's been updated in October by a Datadog report. And what it's showing is that among all those containers, like 1/3 of them, which are the top, images that people run in production, 1/3 of them are databases, right? Which is really amazing. I didn't expect that much, to be honest, but which even bring more, I would say, stress into why we are doing this session today. So Guy, now I'm going to hand it over to you because obviously, operating stateful set databases doesn't come without any issue in terms of troubleshooting and instrumentation.
Yeah, it's tough. It's tough to troubleshoot. It's tough to troubleshoot like deployments and pods, and it's even tougher to troubleshoot stateful set, which you mostly don't know the code. So troubleshooting Kubernetes is very hard today. most of the time you get alerts from one system. It may be PagerDuty or OpsGenie, and then you got alerts from more system like Datadog, and the Slack is going on fire. Everyone asking why the system is unavailable, and you want to check your CI, CD, and everything like that. So basically, when you go into an incident, you have a lot of data that you need to coordinate, need to pinpoint, and you need to find the right issue, what causing it. So it becomes very difficult, especially in these days with Kubernetes. We did like a workflow for only one scenario of out of memory issue, which we actually workflow the solution for that. And the solution is very complex. You need to take a lot of time. You need to move into a lot of space, and you need to do a lot of command, check the output, move to other systems. It becomes very complex. This is only one workflow that our engineering did and find out. So basically what Komodors do is actually helping you to solve and troubleshoot those incidents. We take all the data from all the systems, integrate them into one place that you can see all your services and all of your clusters and all your incidents from any other tools you got. And we actually show you a timeline of your services with all the code changes and the deploys, the health event if the service was unhealthy, and even with the ability to drill down into it. So this is what Komodor does. And we even can drill down into a specific pod and logs to see the logs actual from the system very fast and easy, something which I very like, and we are going to see on the live demo later. So very excited to show you that. Maybe you can explain a little bit about the persistent volume and how Ondat is integrated to that.
Yeah, sure. So we're going to go into the demo in 1 minute. But for you guys to understand what we're going to see, because command line sometimes it can be a bit, a bit foggy. So Ondat at the foundation, if you think about what we are doing, you can think of we are the hyper-converged solution for Kubernetes. So you can think about it as vSAN or this type of solution, but for Kubernetes. What we do is that we take the disk space from every node, so it can be anything that is locally attached to the node, and we aggregate this into a pool of storage, right? And of course, on top of that, we're going to provide additional features for replication, encryption, compression, caching, and we're going to ensure that you have the right performance. So yeah, it's I would say, if you ask me, it's an elegant piece of software, but more importantly, what is specific to Ondat is that it's Kubernetes. So what I mean by that is, so you can see here, I've got on the middle of the screen, feature labels. So anything you want to enable in Ondat, you can do it just by applying labels at different level. So you can go at the storage class, you can go on the PVC level, and you can change it as you want, live. So of course, depending on the situation, you may have to, redeploy the pods, but let's say if you just want to change the number of replicas, that's fine. You can do it live, right? So if you scale a number of nodes, you can also scale the number of replicas up to 5 if you want, right? So if one node fails, we will always make sure that the pod can be restarted on another node safely, and as much as possible will access its own local data. And if it cannot access its local data, then we also have a network protocol whereby the pod can access a remote volumes, which obviously will incur some performance impact, but pretty much minimal. And just as a quick reminder, in terms of the flow for a particular stateful set, how do you define the storage requirement, right? As I said at the beginning, the first time I went into this, I was like, what is this? It's kind of complicated. But actually, it's not that much, right? So let's just take a look at it. So we have on the top the stateful set. The stateful set, as anything in Kubernetes, this is a first-class object where, to be able for every pod to leverage its own storage space, we need a volume claim template, right? Because if you just put a PVC there, then it's like a deployment. Everyone will share the same backend storage. Here, we want every pod with a distinct piece of storage, distinct persistent volume. So for that, you create a volume claim template. And in this template, there's two solutions. Either you just say, I want to use a storage class and give the amounts, like how big you want the volume to be. That works. So with Ondat, you just, once the storage class is managed by Ondat, we will provision everything dynamically. So you just specify the storage class, and then we will provision the PVC, the PV, and that's it. Super simple. Alternatively, as we'll see in the demo, depending on what or who is creating the stateful sets, here we're going to see for MongoDB, we are going to be using an operator. So it's a piece of software itself that is going to create the stateful set definition. In that case, it's using persistent volume claim and making a reference to a storage class. If it's empty, it means it's just going to use the default. But essentially, you're going to see a definition of the persistent volume claim. So the persistent volume claim, you can compare it to a pod. A pod consumes compute units. Persistent volume claim consume persistent volumes units. And because everything is dynamic, everything is created at once. So when the stateful set configuration is sent to the Kubernetes APIs, automatically, if the storage class is managed by Ondat or a dynamic provider through a CSI, then it's going to provision automatically the PVC, the PV, and are going to tie them together, right? And you end up effectively with every pod leveraging its own piece of storage, right? So now if I can just quickly show you a demo of that, let me share my screen, window, try not to get the wrong one. That would be a shame. Okay, so I think everyone can see my screen. So let's just take a quick look at the cluster, what we have today. So the cluster is basically a Rancher cluster running on Linode. And on that, let's say if I do pod system, okay. So this is all the containers that are required by the Ondat and StorageOS engine. So yeah, StorageOS is essentially the engine we are using for our Ondat solution. Most of the intelligence reside into the daemon set. And on top of that, we just have the CSI provider. We interact with the Kubernetes API with those deployments. And we also, so remember when I say we will try to collocate the pod to its own local storage, this is why we have our own scheduler to do this, to manage this kind of, try to optimize the pod with its storage. So what I want to show you is I've got my MongoDB namespace, all the pods. So you can see the operator here. This is the community operator. So you just, hopefully you're familiar with operator, but quickly, the operator allows you to configure your database and encapsulate this into YAML. And extending the Kubernetes API, this operator will take all the configuration item that you have configured into this YAML file that we're going to see in a minute, and just deploy everything accordingly. So in our case, I just said I want a MongoDB. I want 3 instances for this particular MongoDB cluster, and those instances are the pods composing the stateful sets. So essentially, if I do get stateful sets in that namespace, I've got my database, right? The name is example MongoDB, and as part of this, it's deployed 3 instances already. So if we take a look, at the YAML, I just want to highlight a couple of configuration. So this is exactly what I was mentioning. It's managed by the operator. The operator is generating the configuration to deploy that stateful set. So I wanted 3 replicas, 3 in terms of, so here it's replicas as in pods, like a replica set controller inside Kubernetes, right? Because there's 2 levels of replicas. There is the pod container replica as in the replica set in Kubernetes, but there's also, the replicated data from MongoDB. So the database replica, which is not the same thing, right? So here we're talking about the containers. So then we have multiple container that is going to compose all of our MongoDB pods. But what I want to show you is go to the volume claim template, which is very down here at the bottom. So here we go. So remember, we have our volume claim templates, and I've got persistent volume claim that are defined there. I'm requesting a specific amount of storage, which is 10 gig here. So I want 10 gig for the data volume, and I also want 10 gig for the logs volume. And you can see here, I don't specify any storage class, so it's coming from the default storage class. Oops, sorry. So if I just get the storage class globally, I've got two storage class. When you install Ondat, you will have by default a fast storage class and a default storage class that I've just mapped into the Ondat's solution. And if we go a bit deeper there, what we will see. So remember, I've said before that the only thing you need to do to configure Ondat, because it's super simple, super easy, but also super powerful, is just by manipulating, in the case of the storage class, these parameters. So any features you want to enable or change, you can just apply here at the storage class, or you can also do it at the PVC layer, right? That works as well. But essentially, this is what I mean by Ondat is a Kubernetes solution. We're not using anything but Kubernetes object to implement our features. Okay, so the last thing I wanted to show you is, of course, we have a command that allows you to take a look at what is provisioned from the Ondat perspective and see the number of replicas and which node will be master or primary for a particular persistent volume. So for example, here we have 3 pods, right? So the PVC, this is from all the PVC where it's empty is from my previous test. The PVC have not been released. But what is interesting here is just to see that all of those replicas you have, when you say attached on, it means that this is where the primary replica is located. And also what you want to see is here that we have 3 replicas for all of this persistent volume claim. I think this is all I wanted to show you in terms of the relation between stateful sets, PVC. Oh, the last one, maybe get the PV, right? The PVs themselves is just essentially those are the piece of storage that have been effectively provisioned for consumption from the PVC, right? And that's basically it. Okay, so let me just stop sharing my screen, back to the slides. Okay, so as you've seen, the first thing you really need to be aware is that if you want to deploy a database or really any sort of stateful workloads into Kubernetes, make yourself a favor. Don't try to do this by using deployment. You have to use stateful sets. But again, as I've shown, there are still challenges. You need to take care of the enterprise grade features you need to have to run this into Kubernetes. Replication, performance, compression, encryption, all of that. And the second part for your platform, which is really tip number 1, use stateful set, but also a database operator, which will take care of the database deployment, like we've shown here, but also, as we'll see later in the other demo, all the day-to operations, such as you want to scale your database, right? So if you need to scale the number of replicas, like typically in MongoDB, you have 1 write, but then you can add more replicas as reads, right? To give you more performance for reads. So let's say if you have 3 replica for your data set, if suddenly you say, okay, now I've got more customer that is connecting to my app, I need 2 or 3 more replicas. If you do it in Kubernetes, that means that you have to do 2 things. You have to scale the number of pods from the stateful set, but also you have to scale the number of instances into this database, right? So those are a twofold sort of action. And actually, the operator will take care of that for you. And we're going to see this later. But yeah, and just a quick reminder again, the operator, the principal, is a piece of software that is running as a pod or as a deployment, should I say. It's going to listen to the Kubernetes API and is going to be extending the Kubernetes API to create your own custom object. Like the MongoDB itself will be a first-class object into Kubernetes. And the way you configure and you interact with MongoDB then is by using a declarative format, which would be YAML, right? That's pretty easy. So yeah, just use an operator. Don't do it yourself. Now the counterpart of that, that's for the platform. For the app, of course, you want to make the app aware of where it's running. So it's running inside Kubernetes, which means that it can leverage different benefits. If you want, for example, to reference maybe another application, another microservice, Kubernetes is providing service discovery and injecting this as environment variable. So this is something you should use. Which is called the downward API, which allows you into your YAML file to reference existing Kubernetes metadata for your application. So like IP addresses, service name, all those kind of things you can populate. The second thing I wanted to mention, so as I said before, there are 2 ways to run databases in like a cloud format. You can do it in Kubernetes, which is the de facto cloud operating system, or you can do into a PaaS, DB as a service type of environment. If you take the example of RDS or any solution that is leveraging, let's call it cloud persistent disk, that usually is a network disk that is attached to your nodes, then it can be very costly. So always make the comparison. So here, as an example, I've just been using the traditional, cost explorer from AWS. So if you want 100K IOPS, which is not that much, knowing that any NVMe drive today can do 5 times that. 5 instances doing this with 500 gig, which is not that big. This is the cost per month. That's 24 grand per month. It's not cheap. So what is the alternative? Well, you can use things like Instance Store, which in a nutshell is just you just pay for the local drive that is attached to your EC2 instance, right? So you just consume your normal EC2 price or cost. It's just this. You're not charged on top of that as disk. And then what you can do eventually is use Ondat to create a pool of all the storage from all your nodes, from all this Instance Store, and on top of that, implement those enterprise grade features, but really at a fraction of the cost. We are probably talking about 10x, even more, right? And another paradigm I want to mention as tip number 3 is bring more automation into the picture, because we know that in Kubernetes it's really easy to automate because we have this declarative format. And if we compare it to software practices, then we can combine infrastructure requirement, so platform Kubernetes requirement, together with code requirement. So, in software development landscape, we have this notion of shifting left, which is the idea is just about, bringing all the testing like earlier in the process, closer, to the left, essentially, where you are effectively developing. So the idea here is shifting left your infrastructure, mean that it's bringing or reducing the friction between the developer on the one side and the platform admin on the other side. So what that means is that now the developer can just use the YAML file I've shown you before, like storage class, PVC, and said, okay, I need that amount of storage. I need this feature. Maybe if it's for test, I don't need a replica. If it's for production, then I need X amount of replica. I need encryption, all those kind of things, right? So by doing this, you're reducing the friction between dev, platform, and you go faster into your software development life cycle, right? And this automation is made possible also by GitOps. So GitOps is just this idea of, instead of pushing stuff yourself in Kubernetes, using kubectl, you just, again, make use of an operator that sits into your Kubernetes cluster, and that's going to look for changes. If you see on the left here into the Kubernetes manifest, is going to watch for changes there. So, a traditional pipeline would be that a dev, so on the top, create its application, trigger the pipeline, the CI pipeline. The CI pipeline build a new container image. The container image will, through customize, the customized solution in Kubernetes, through customize, will update the Kubernetes manifests. The operator will notice that the manifest has changed, and as a result, will reconcile what is living in the cluster, the state, with the intent, which is what is sitting inside the Git repository where you have the Kubernetes manifest, right? So it's even bringing the automation one step further to help you shift left in terms also of security and compliance, because this is all residing into your Git repo, you can apply a plethora of policies. You can use open policy agent, which is going to be using Rego to implement your policy compliance, doing syntactic check, all that, saying that, okay, if it's going to production, I need to only have encryption enabled. If it's not enabled, I'm not going to deploy that. So it enables, a lot of different capability that you were lacking before. So again, it's helping you migrating your database into production, because now you have much more security and compliance, right? But also, you also have requirements in terms of the instrumentation. So now, Guy, it's up to you.
Yeah, so basically my tip is build your stack for Doomsday. When you're operating database, Doomsday will come. You will eventually going to a downtime and going into an incident that involve your database. And actually you're going to be responsible for the database and responsible for the operator. So you want to add visibility to anything related for that, like any visibility to add one of your services. For example, the performance, the IO, the backups, everything related, you want to be metriced and monitored, and you want to see everything in one place. The next thing is about, you want to make easier troubleshooting. Downtime is very bad. It can become very stressful. All the company is waking up at night, and you want to make sure your production is up and running. And you need to build your stack and the tools for that. You need to know what have changed recently. If it's the number of replica, it's the code related to that database. If someone changed any configuration in the database, you want to see everything in one place, and it's very important for that. You want to have very fast access to log metrics and your monitors to know what's going on and why. And actually, maybe you want to create some hub for your all your other services, like you want to see the logs and metrics in one place, or you want to go to Swift from one another without moving into a lot of filters and going to deep searches. This is something that you need to build and make your troubleshoot much easier in the incident time. The next thing is, as we talked about shift left and automating things, and we want to make everything automated related to the database too. For example, if you have backups, you want to test and make sure that you know how to recover, and you know how to recover, not in that incident, and like any other day. When you wake up in the morning, you want to know that your environment is stable and you know to do all the operation. It is also empowering the developers about what they are capable to do, what they're responsible for. It can be a platform developers, and can be like app developers. All of them need to practice and know what they can do in their own database. after a while, you're going to build your database expertise. So database expertise is not something that comes in one day. You need to build it and you need to train it, and you need to train your system or your automation and script to know it. So when you're deploying for development and staging and then moving to production, make sure you know everything and you know your database and operator very well. These things can change quite often, and we want to make sure that everything is there. So let's move to the next one. The next one is about choosing your database. Choosing your database is not as easy as it seems for first time. So we have the common one, and all of them, most of them have operators, but operators can vary a lot. They have different capabilities. Some of them can be only installed, and some of them can be day-to operation too. Some of them are community, which are open source, and some of them are enterprise with a lot of enterprise features. For example, more security, maybe access like a web UI. You have all of them in your enterprise, and some of them are supporting upgrades, which is something that you want to have when you're moving to production, and some of them not. Each database most of the common database have a few operators. For example, Postgres have many operators out there, and it's not about only choosing the database, it's about choosing the operator too. When you're choosing a database, you need to know how it's going to fail and what is the action you need or the stateful set will take for you in order to make sure it's going to back live again. You need to know if it's like active backup and you need to do like failovering in the old classic way, or a more consensus algorithm, which all the nodes can like decide who is the leader right now, and then it be a more healthy and fast and smooth failover. You need to know that when you're choosing the database. So database can be like Kubernetes friendly or not. Kubernetes is like designed to fail, and your pod's going to fail. Your stateful set pod will fail eventually, and some database knows how to support that well, and some of them not. You need to make sure that you're choosing the right database that is Kubernetes friendly, have all the features, really know how to adapt failure and move around. And also something that you have to take care about is the day-to operation, something we sometimes forget in the first deployment. And we really want to know what are the day-to operations that necessary from us. They are not covered by the operator, and what we need to do in that case, and what is on us, and we are going to test and automate. So choose your database wisely, make sure the database operator and all the ecosystem fits to your need and fits to your scenario that we are going to, you are going to feel in the future. So next thing we are going to show the demo. Nick, I think you start first, and then we will move to Komodor and see everything in Komodor.
Yeah, so what I'm going to do, because I just realized, I was a bit fast on the previous demo because you didn't have time to show it. That's fine. So what we're going to do there, we're going to move into like a demo of, continue what we've done before. So, but this time more around, let me share my screen, around the day-to operation for the database. And just after that, we're going to see all the power of Komodor, because we're going to see all the, and actually that's a good example because we can move straight to, what you will see in Komodor as I scale up the database. But first, I just want to give you an extract of, what is the operator configuration. So this is effectively where you set your database configuration. So this is what Guy was mentioning before. Depending on the operator, you can create different things. You can interact with different parameters. So here, the only thing really that I'm going to interact with is the number of members. So remember, members will determine both the number of pods in the stateful set, but also the number of replicas of the particular database. And then you can configure things like users, password, and then for the stateful set specifically, you can add here interact with annotation, volume claim templates, resources. So basically, instead of creating yourself all these parameters into distinct Kubernetes native object, we leverage the operator to create a custom resource that is now sitting in the Kubernetes API. And the DB operator will take care of all the automation for the deployment, but also for day two. So what we're going to do now, let me just connect to the database once to show you what is the current situation. So I can just do here, connect to the database from another pod, like kind of simulating your application connecting to the database. So you're going to see that, so remember, I've got 3 pods. So 1 primary and 2 secondary replicas for the database. And so you can see it here, ID 0. So we have the stable identity, which is provided by the stateful sets. Like it will start with, it will have an ordinal number, 0. Then the other pod, the second pod will be -1, -2, -3, etc. Right? So we have 1 secondary. So the pod 0 is secondary, pod 1 is primary, and pod 2 is also another secondary. So this is what is composing our database now. So what I'm going to do is just scale it. So for that, again, declarative fashion. And it's going to take some time to get provisioned. So while it's going to be provisioning, Guy, you can maybe show what's happening. Oh, not 2, sorry. I cannot talk and write at the same thing. Apparently, only women can do that. That's my wife who said that. Men, we're not able to do these kind of things. So member 5, okay. And just, I've got my screen here, okay. That's good. So now it's going to apply the configuration, and I should see pod which start creating. You see here, init 2. So Guy, up to you. So you can show what's
Yeah, sure.
happening.
Now I'm going to share my screen, and we will see the deployment in Komodor. So just a second, not miss the right tab. Okay, so actually this is the main screen of Komodor when we can see all the services and the services health. Actually, we can see all the clusters, namespaces, which services are healthy or unhealthy. We want to filter by them, and any kind of resources that are runnable. For example, deployment, stateful set, and daemon set. Why now? I want to go in and drill down into the example MongoDB, which is a stateful set. And I want to go into it and see what's going on. So here we can see the service. We can see it's healthy right now. If it was unhealthy, we will be able to spot it here very fast with the red light cube here. And we can see what the history of the service was, which is very important when we are taking a look about incident that running for a long time, and we want to see all the things related. If we will add more system to Komodor, we will be able to see incident from them. For example, if you have a Datadog alert, we will be able to see it on the timeline, which is very useful on the same service. Something is very useful for us. If I'm going to drill down into the deploy, I'm able to see the deploy metadata and what actually changed. In that deploy, you increase the replica from 3 to 4, which is nice, and we can spot them here. We can see actually all the definition, and we have the diff of what changed. What is very nice that you can see the deployment. If it's tracked by GitHub, we are able to see the same, the commit changes in GitHub in that manner. So we'll be able to track the configuration change with the GitHub change. And what we can see.
Yeah, so it's really nice, right? Because it helps you correlating the app with the platform, right? Which is, yeah, that's pretty impressive.
Yeah, we even have the option to add a few repos. So you will be able to do the app repo changes and the info repo changes if you have a common or shared chart for all the company or templates, which is very nice to see the impact. I think what's nice in here that you're able to track changes. It's very difficult to track changes in Kubernetes right now to know what changed a few days ago and who did that. So I can move all back to all the deployments and all the changes through them. And let's say I have an issue and I want to actually drill down and see what's running on my system right now. So I click on pod status and logs, and then I can see all the pods that are running right now in the system without using any kubectl. I find it difficult to move between clusters, do like a kube command and see the pods, and then move to another namespace, do that command, maybe like comparing two clusters, and one is Delphin, one is not. So I can see all the pods, which running, how many restarts they got.
Yeah, so now we see that we have the 5 MongoDB, and I believe you guys also have like a related, like if you want to jump to another microservice that is related to it, you could do that as well, right?
Mm-hmm. Let's say I have an application, you have, let's say I have, I don't know, some other application like the Kubernetes Watcher. I'm able to integrate the same deploy to other deploys timeline. So if I have correlated incident, I can see them here in two different timelines. I can add a lot of things into it and move into like 7 days back, and I can see like the Kubernetes Watcher was unhealthy for a little bit, and all the deploy for the operator too. So I can see the operator deployment. And then when I move to pod status and logs, I can see the describe of the pod, which is very useful to know what happened when we configured the CRD and what moved into our stateful set. So it's not very easy to do that. So we can see everything in here. We can see the events of each container, which is nice, especially on crash loop backup and things like that. And what is very nice, that we can see the logs of the running container. You can drill down into a specific container and see what's going into it. For example, we added 2 new replicas, and we want to see that the replica added fine. So basically, I want to maybe search the log. If I have an error, I want to see it on the log. I don't want to move into a lot of logging system. So it's very nice. And if the pod was killed or restarted, I'm able to see the logs of the previous pod, which is very good when you have a problem and the pod like killed or exit with some exit code, then you'll be able to tail the logs of the last one, which is something that a lot of customers are using. And I like that. And I like that Komodor can bring like very nice option to troubleshoot databases without be a database expert right now.
Yeah, which is, I think, when you migrate to your database to Kubernetes, you don't want to have, this extra burden to have to learn again everything, like both the database, learn the platform. So a tool like that is, that's pretty good stuff. So, yeah. So now, just to double check that everything was okay, let me share my screen again. So in terms of the database, so with Komodor, we've seen that now everything from the infra side is okay. In the container logs, we also saw that, from a database perspective, we should have the replicas as well, the new one. So let's just check that, again, we should have 5 replicas total, right? So you can see it here, 0 secondary, 1 was, 1 primary, then 2 secondary. Now we should have 3 and 4 as secondary as well. So now with just what I've changed 1 line, and I've got more read replicas. So when we talk about day 2 operation and doing like housekeeping around the database, it's pretty easy. Right? Now I just wanted to show in terms of the storage, the Ondat/storage OS configuration. Here you can see that now because I did some scale up and scale down, it took, again, remember when I said when it's a stateful set, you have a stable identity and you're always attached to the same PVC. So I scale down, which is like killing the pod. I scale up, and again, it took the same PVC. But because I don't care where I am, where the pod is, I've got many different replicas on that side. It can be restarted anywhere, right? So which is not the case if you don't have Ondat, you will be struggling to do this kind of thing. Same thing with EBS. If you have an EBS volume, you have to, in your EKS cluster, you have to use some sort of snapshot and recover the disk to another node, another AZ, these kind of things, right? So yeah, we're simplifying a lot of that. Okay, so I think what time is, 10 minutes. I think we're doing good. Let's go back to the slide. It's just basically, the last piece of text for today's. So hopefully, guys, today you learn one thing or two. We've been showing, demonstrating some of the Kubernetes primitives and some of the ecosystem components you can use to deploy stateful apps, and in particular, why it's useful for databases. When you deploy your database in production, make sure to pay attention to all the features we've mentioned, especially around cost, around operation, troubleshooting, performance encryption. Try to leverage the Kubernetes automation capabilities, operator framework, or should I say paradigm, and also try to get your logs and all your data that is relevant to instrumentation. Try to use them in a meaningful way, and for that, Komodor will for sure bring a lot of value into a single place where you have access to everything. You have access to history, you have access to correlation in terms of the incident. So again, you're going to save a lot of time in terms of operations and just day-to-day operations, really. I don't know, Guy, if you want to add something, and then we can open it up for questions as well. Okay, so if you want to get started, this is where you want to go, ondat.io for Ondat. And for Komodor, you can go there and sign up for a free trial, and I'm sure they will be happy to give you a free license to test, right, guys?
Yeah, sure. Just contact us and we will reach out to you and we will do a free trial for you.
Okay, so do we have any question? Okay, so hey, I have an issue where my DB has a very high latency, and I see it's because some of my pods are down and getting kicked out due to lack of memory. Will Komodor alert me in it? How can I find the root cause of this? So it's for you, I guess.
Yeah, actually, we have a very nice feature that's called workflows, which enable us to help you troubleshoot out of memory issues very fast. We are taking, when you have out of memory to any one of your pods, we actually automated checks for you. We are checking the quality of service. We're checking the node statuses in the system, that the pod have like enough memory to run and the limits of the pod. We check configuration changes and a few other checks at everything that comes to you in like one specific health event, that actually you got all the digested information to the right place. So it doesn't matter the actually reason for that. We will help you to figure this out as fast as we can with all the automated checks and everything in it. Very nice feature. You can find it in our YouTube, and if you are signed up for a free trial, we will show you that real live demo. And even on your system, I don't know who asked that. So,
yeah, I think that's a good use case. So definitely something to follow up upon. Okay, so before we close, I don't know if you guys have, and girls, if you have more questions, it's now or never. Well, seriously, yeah, you can reach us, on social media, websites, anything, right? Same for you, Guy.
Yeah, sure. I think we both like very communicative companies. So any channel, social media, our website, I think for both of us, it's both fine.
Okay, let's give it another try. So last time, once.
Okay.
Twice. Thrice. Okay, so I think we can close like 5 minutes on time. So that's perfect. That was great timing. So thank you again for joining this webinar today. Hopefully you've been learning one thing or two or more. And yeah, we'll see you next time.
Yeah, thank you very much. Thank you very much, Nick. Thank you, everyone that came to the webinar.
To you, Guy, too.